Hi viewers, in this video we are going to learn about the working principle and construction of a DC generator. Okay, so here in this video what I am going to show you is clearly explains the working principle of a DC generator as well as the construction. See here what happened. So coming to the construction, see here the generator is manually moving the shaft. This is the shaft which is manually moving, and the thing which is rotating here is the rotor, and which converts the mechanical energy into electrical energy. So an electric current flows when the terminal is connected to a circuit. So this is the generator, electric generator. So now what we are going to is mechanical energy is converted into electrical energy. So this is the actual DC generator. So this is the yoke. So both the things are highlighted here if you see. So these are the core. These are the core, and this is the field coil, and coming to the next one is the armature. These are known as laminations. So laminators, and this is the armature coil. It's like this. This is the commutator. See which is present here. Commutator. Okay. These are the brushes which is highlighted here, and this is the bearings. So both the things are highlighted here. So this is the magnetic circuit which produces the magnetic field. Okay, and this is the air gap. The highlighted area is the air gap. Now we are going to explain each and everything particularly in this video. So first about yoke. What is yoke? So it is the outer frame of a DC generator. So the yoke which protects you from the outer protecting shield for the generator, mechanical support for the poles. See what are the poles which are happening mounted here. Small generator yokes are made of cast iron. In large generators, yokes are usually made of cast steel or rolled steel. Okay, this is all about the yoke. While coming to the next one is field poles. See, this is the field pole. So basically flux is produced by these field poles only. So it reduces reluctances for the magnetic path. So these are the field pole. The highlighted portion is the field pole, field coils. Okay. So how these coils are made? See here the gold is copper wire. See this is the copper wire which is mounted on the former, and then fix it to the field coil. See which is highlighted here in the actual DC generator. These pole coils will become and mounted on the pole like this. So while current is passing through the coil, so the green highlighted thing is the flux. The magnetic flux is produced around the coil. Now coming to the next one is armature core. So this is the armature core. This type of laminators combinedly collectively to form the core. See these are the armature slots. The gap present between these are the armature slots. Cylindrical drum shape built to circular sheet steel discs or laminations approximately 0.5 mm thick. So these are the air holes, and this is a key which is fixed to make the laminated sheets to be fixed. And the next one is the armature windings. See these are the armature windings which is highlighted here. So these are the armature coils. Two types of windings are the lap winding, wave winding. While coming to the types of windings, there are two types of windings are the first one is the lap winding, another one is the wave winding. Now this lap winding is like this, north pole to south pole and again south pole to north pole. This is known as lap winding. So this is the number of parallel paths equal to number of poles equal to number of brushes, which will gives you about the types of windings. Wave winding. See here how it is north pole to south, south to north again, like this. He will show you everything in this video how the windings are winded. Next one, commutator. This is the very important part in the DC generator. It explains you about the see all the windings here come and collected through the commutators. So AC to DC. Collection of current from armature conductor converts the AC current into unidirectional current. It is cylindrical structure has built up wedge-shaped segments of high conductivity. So these all are discussing about the commutator. See these are the segments, current copper segments. Next, carbon brushes. These are the brushes. These highlighted things is a brush. collects current from the commutator. These brushes collects the current from the commutator. They are usually made of carbon or graphite and shape of rectangular box. So this particular part is this one. They are housed in built-in brushes. So these are the carbon brushes. This graphite colored one is the carbon brush, and this is the flexible pigtail which is going to collect the current from the carbon brushes. Number of brushes per spindle depends upon the magnitude of the current be collected from the commutator. It depends upon the current collected from the commutator. These are the bearings. The next one, this one is the bearings. They are frequently employed because of their reliability. Balls and rollers are generally packed in hard oil. Sleeve bearings are used in order to reduce bearing wear. So this is the schematic diagram of a DC generator. So here you can see everything up to now what we are seen in the video, brushes, everything.